Yesterday we talked about simple harmonic motion with an oscillating spring system, and part of your assignment yesterday was to try to analyze the swinging pendulum with the same type of phrases and where the energy was maximum and where it was minimum. You were supposed to analyze a pendulum or a swing with the same way that we analyze the oscillating spring system. Now, it's really crucial that you understand this, and so I wanted to go through it today and make sure that you understood this because, like I said, it's really crucial that you understand the difference between the kinetic and potential energy and where it's changing, and so I just want to go through it and make sure that it's clear. So this drawing is supposed to represent a swinging pendulum. So you can think of a clock that has a pendulum that swings back and forth. You can think of a child on a swing as he's swinging back and forth. How far up you swing could vary. You know, you may only be swinging this high and going back and forth, or you may be going all the way up here and swinging back and forth. Okay, so how high it goes doesn't have any effect on the way that we're analyzing this, all right? So in this particular scenario, again, this is going to be vertical because it is swinging. Yesterday, what we were talking about was horizontal, but a swing or pendulum is going to be vertical. So here is going to be your rest position or your equilibrium position in a pendulum down here at the bottom. Okay, and so at the rest position, this is where you have no potential energy, because you remember gravitational potential energy when we talked about it before, and the higher you are off the ground, the more potential energy you have. So in a pendulum, the highest position is where your potential energy is at its max, and at the very top of the swing, there's not going to be any potential energy. And so the restoring force is going to be directing the pendulum back down towards equilibrium position, okay? So as I go down this direction, my potential energy is decreasing, my kinetic energy is increasing until I get to the point here where I now have no potential energy anymore, and now my kinetic energy is at its maximum value. And so if the kinetic energy is at a maximum value, then the velocity is going to be at its maximum value as well. Then as I continue to go back up to the top of the swing on this side, once again over here, because it's at the highest possible position, the potential energy is going to be at a max, and the kinetic energy is going to be zero once we get back up here. And then the restoring force, again, is going to be acting in the direction down here to bring it back down to the bottom. The amplitude, once again, is the maximum amount of distance, the maximum amount of displacement that the pendulum bob gets displaced. So from here down to the rest position right here, this distance is going to be the amplitude, because that is going to be how the maximum amount of displacement that it can have from the rest position. Now, you have, I'm sure, at some point ridden on a playground swing, and you know that if you want to go higher, you can pump your legs to make yourself go higher. And so when you do that, what you're actually doing is applying something called resonance, where you are pumping your legs in time with the swing so that you're actually adding energy at the appropriate time so that you can actually go higher, because you're giving the system more kinetic energy by doing that pumping. If you've ever watched a little kid trying to learn how to pump, you know that a lot of times they don't quite pump their legs at exactly the right time. And so when they do that, when they pump them at the wrong time, they end up actually slowing themselves down as opposed to trying to go higher. Once they understand when to pump their legs, then they're able to get their pump at the right time and start swinging themselves higher in place of going lower. So when you're trying to add energy to the system and actually swing higher, that's adding resonance. If you're trying to slow down, So you may drag your feet. You may just kind of let air resistance just kind of slow you down naturally, or if you're in a hurry to get off the swing, you may drag your feet, and then you're going to be damping the motion in order to stop the motion. So resonance is going to increase the motion, where damping is going to decrease the motion. One thing that you will see in this chapter is that I have given you a lot of links to a lot of other videos, because they have the capability to show you some things that I don't have the capability to show you. I don't have the lab materials and things like that in my home, and so I'm giving you some links to some other videos where people have done a really good job of trying to show you some of the principles we're talking about. And in one of the videos that I've linked today, the gentleman does an excellent job of explaining why in tall buildings they have to use a damping mechanism, because tall buildings almost act like a pendulum, and they will start to sway back and forth if engineers don't do something about it in order to stop that kind of motion. So make sure that you are really looking at all the extra videos that I sent, because I really think they will help your understanding of the types of things that we're talking about in this chapter.